Hello, good morning, everyone. Thank you for joining this session. My name is Derek. I'm the APJ Principal Technologist at SUSE. Today, I'm going to cover about how application developer or the DevOps teams can make use of the GitOps-based application delivery approach to handle the distribution of their application into multi-cloud environment using an open source tools called SUSE Rancher. So I hope you will find this session helpful as part of adding knowledge to your development domain. So let me start with why multi-cloud strategy is the company looking for the way to go. Well, the idea is very simple. Basically, you want to distribute your workloads across two or more clouds in order to reduce risk, or you want to minimize the downtime to provide better resilience, to give a better SLA or the service to your customers. And also, you may also want to eliminate the use of your in-house on-prem infrastructure and move directly to more cloud environment to enjoy the elasticity, the pay-as-you-go flexibility that you can earn from there in order to gain the potential cost savings as well. So these are the good points for handling the workloads across multiple clouds. But then here it also comes with the challenges. The challenges is that um, it if you move into different cloud may have their own specific technologies, specific protocols, specific um, um, database or things that you need to handle. That adds the complexity in the infrastructure, in network, and to the whole overall data center. For example, the security, you need to expand the scope of consideration of it. Not only that, but it also makes things enable easy for the IT team to be able to have a central control of the entire landscape of your infrastructure. So some of the departments, some of the user may spin up their own application that runs out of the governance of the organization in the cloud. That is not ideal for the company to protect the customer data, for example. So it's essential to have central control and visibility to govern whatever they are running their application in the cloud environment. And needless to say, security is also a challenge. And because it dispersed across to multiple environments, to have a consistent security governance is also a challenge for a lot of organizations. Last but not the least, for the DevOps teams or for the developers, they are more concerned on how they can consistently be able to deliver their application to distribute it to uh, different cloud environments, and they are still under control. They know is the version is exactly the way that it is going to be delivered. These are the key things that they need to resolve in order to have a good multi-cloud strategy. And so here today, we're going to talk about a modern solution that will tackle this angle, the multi-cloud strategy adoption. So first is that for wherever that you run, nowadays you can make use of the open source technology called Kubernetes to be able to abstract your underlying infrastructure, no matter it's on your own on-prem data center or on your public cloud. Basically, you can standardize it. You expose the same infrastructure management capability wherever it is. Even in the edge area of the branch or some edge location, you can still use Kubernetes to abstract it so that you can have a conformant, consistent infrastructure base wherever you are running your application. And then you need to have a tool to help you to centralize all your control, to give better visibility on across all your infrastructure, to oversee all your applications running across multiple clouds. And with this, then you can apply a consistent security governance measures on your infrastructure because it's been standardized. You have a better way to apply this security control consistently wherever it is. And there's one more thing that we can do, that is the GitOps-based application delivery. With the GitOps-based approach, you can have a better way to deliver your application onto this kind of platform. So all this modern solution has already been proven and used by an open source technology called Rancher and the Fleet solution. So basically, these are the key things that it can address to. But how this solution would work? Actually, in our infrastructure environment, assuming everything is running on Linux system, it could be some commercial Linux, it could be some open source Linux distro that the IT team is familiar with to operate in. Wherever it is, we can always abstract the entire infrastructure with a certified Kubernetes distribution to help you to abstract and make the infrastructure more automatable, more immutable, to be able to provide the flexibility, portability, the consistency that you need across different infrastructure environments. For example, with the SUSE Rancher suite, they have the RKE Rancher Kubernetes engine, which is a certified Kubernetes distribution to help you to make your infrastructure to be abstracted with the Kubernetes easily on your own data center. And likewise, if you need to enable your edge area to run your same application in the container world, then we also have the K3S, which is a lightweight version of the Kubernetes to help you to run Kubernetes platform to enable it to run your application on the edge environment, such as the branch office, such as your development environment where the equipment over there has a very limited resources to run, but you can still make use of the lightweight version of this Kubernetes to run your application as well. In the public cloud, they also have the Kubernetes environment to offer as well. It's also a very popular option for application developer to deploy their application onto it. So these are the key infrastructure space where we need to manage and we have to centralize manage it. And that's why we have this very popular open source tools called SUSE Rancher to provide a single pane of glass of control on all these different Kubernetes clusters across the entire organization, be it on data center, on cloud, or on the edge environment. It can be visualized consistently and manage it in a automated, consistent way. For example, for each environment, if you need to have Kubernetes version management, you need to upgrade it or you need to provision it into a new cloud environment to run your application in that is closer to your customer, then you can use these tools to help you to easily get the job done in an automated way, following the best practice from the industry. Not only that, it also provides the secure control to enable your big team. Different team can have different access to different clusters, to different part of your cloud to carry out their own development work or to manage their own projects in their organization. It has the integration with the external integration provider to help them to onboard all the users according to the organization's preferred identity management provider. It can support the LDAP, SAML, or the AD-way, whatever you name that is commonly used in the industry. It can be easily integrated to help onboarding your customer to access your whole infrastructure environment. And there's other security measures to help you to make sure your Kubernetes configuration is runtime secure. It includes the CIS benchmark scanning regularly on your cluster to ensure the settings are hardened enough to run your workload securely on this platform. So there are more to say. But for the developers, it also comes with other add-on that can help you to run your application on the cloud native platform more effectively. For example, it comes with the service mesh Istio package to help the development team to run their microservices more securely, more controllable in the cloud native environment. Likewise, we also have the projects for providing better monitoring with the Prometheus and Grafana. All these tools that is also coming with the SUSE Ranger. Those things are basically to help the development team to run their application much more easier and much more smooth in the runtime environment. So these are the foundation that we are going to have. And with this, that's why we have a lot of customers, a lot of users that we see in the community is using Ranger to manage multiple Kubernetes clusters. It could be running on any major cloud providers. It can be running on their own data center. Wherever their application is running, it can be managed by Ranger alone to help them to make the operation much more easier and under control. So let's take it as an example. For example, you have this centralized server, the Ranger, to be able to manage all your workloads across multiple clouds. You have maybe in this example, you have some application running in Singapore on the AWS cloud, for example, and then you have the same application that is provide better resilience, but is running on Sydney on another public cloud, Azure. And you also have some workloads running on your own data center as well. So the team, the IT operation team and the development team can make use of the Ranger to be able to manage all this application across multiple environments. Wherever the user are to access which environment, they can still use the same tool to consistently manage their workloads across different cloud technology and different places. But for developers, if they need to deploy their application, one of the features that I'm going to cover more today is about the Fleet. Fleet is basically a GitOps tools to help the development team to deploy and package and deploy their applications onto different environments. So with Fleet, it can simply set up as a control to monitor the Git repository to be able to scan is there any changes in the deployment scripts. And then it can also direct the deployment into different environment or even to apply different configurations according to the environment's needs. So that is what the Fleet can help as part of the Ranger to be able to make the application delivery through the GitOps approach to deploy the applications onto different environment under the IT operation team's control. So if we look at this in detail, you can see that Fleet is at the core of this Ranger management server. So you can set up the project to monitor the Git, which contains all the deployment scripts that it will have. It could be in Helm, it could be in Kubernetes manifest format. And then it will regularly to monitor the script, whether there's a change on it. Once the change trigger, then you will try to reconcile to the state that where it should be. Maybe you define that, oh, whenever this script has changed, then it should be provision the application into your target clusters. So the target cluster that you are going to do will be selected through the labeling mechanism. You can label your cluster that you want to target to, and then you can define in the controller what kind of label that it has to match in order to deploy the applications on it. The deploy mechanism is also very scalable. So each cluster would also have its own agent to pull to check the desired states, whether the application should be in effect in their respective cluster. If it's not, then it will try to pull the desired state, make sure the controller will apply the new changes on it. So with this mechanism, that's why uh, the GitOps-based approach with Fleet can support up to 1 million clusters from a single control plane to deploy their application. This is very useful as we observe in some of the industry when they need to deploy their applications onto the edge device. This becomes very handy to help them to control where their applications has been deployed into each individual small devices. So this is the basic mechanism and idea of the fleet. For more information, I've put up a link over there to have the technical architecture review if you're interested. So with all this, let me show you how from end to end it works. Let's learn together how this open source technology, Rancher and Fleet can put together to manage your clusters and also manage multiple cloud environments, as well as we will see how we can deploy the applications on it. To start with, let me have a look at this lab scenario. So with this scenario, what we are going to do is we are going to spin up a Rancher management server, which can help you to manage the multiple Kubernetes clusters distributed across multiple clouds. And in this example, what we are going to do is we set up just one single individual virtual machine instance to just stand up the Rancher management control plane to manage all your Kubernetes clusters and applications on it. Now, you can see that this is just a single point of failure, but this is just more for demonstration purpose. Indeed, if you want to make it more resilient in the production environment, usually people will set up 3 uh, virtual machines to run as a base Kubernetes cluster, and then we run Rancher on top of it. This can provide all the resilience built in from Kubernetes from its foundation and to provide the high availability for this control plane. So in production, you can see that this will usually be running on 3 virtual machines, but for now, we are just only one for run. And for each sample clusters, I just make it very simple, very lightweight. We have just 3 virtual machines running on it. In Kubernetes, they have the control plane, the master node. In production, there will be usually at least 3 master nodes running. So, but for the sake of this demonstration purpose, again, I just run one to just demonstrate the functionality. So, and then we have 2 worker nodes running inside this cluster. So the same happen in AWS Cloud and in Azure Cloud. We will be using Rancher. We'll show you how we can use Rancher to let you simply point and click to be able to provision the Kubernetes cluster that is running on these cloud providers and being managed by Rancher so that the developer team or operation team can simply go through the user interface to handle their application from there. So of course, the user side, when they need to access to these workloads, they can still access it either directly or just like in this community, make use of the API management tools to direct the traffic to the right site to these applications. So this is the basic setup for this lab exercise. And then what we are going to do is to show you how we can set up the Rancher management tools, the software, on a single Linux virtual machine. And then we are going to configure it. We will grab the respective cloud credentials from the different cloud providers, and then we configure it into Rancher. And then lastly, we will also make use of the Rancher to provision these clusters onto the cloud environment. In this case, it's the AWS and Azure. Followed by that, once we have the environment ready, then we will show you how the DevOps team can simply configure a Rancher continuous delivery, the fleet system, to be able to constantly monitor their deployment scripts, and then to deploy the application at their wish into the target cluster. We will also explore how you can further customize your target configuration for each application running on individual environment as well. So let's start with the very first part, the lab setup. Is very easy. If you want to follow, you can also download the slide that we have. We provide all the recipe, the steps here for you if you want to experiment it. So the first thing we are going to do is to install Rancher server. The latest version is 2.6, which is just released a couple of weeks ago. And then we are going to deploy it onto a single virtual machine. So there are scripts to help you to automate all this. We just copy and paste into it. The Linux environment that you need to run is just using 2 vCPU and 4 gig memory. But it can be running on any popular mainstream Linux distros. Basically, as long as it can support to run Docker, then it will be run in this case. Just want to make a further note that if you are going to deploy in production, the Rancher is not running on Docker, but it will be running on some Kubernetes cluster with high availability so that it can be more resilient as a control plane for all your clusters. And the security rules here is very basic. It's just opening the standard port. Let's take a look at how it can be done. So in here, I've got a Linux box here. I also, on the left-hand side, I have the menu. What I'm going to do is to install the Kubernetes tools here. So I just copy the script, and it will install the Kubernetes tool like ham kubectl for me. And then I just copy the scripts that I need to deploy the Rancher server as a control plane for all my multi-cloud. It's very simple, just one line command to just plug it into the Linux. But wait, it looks like, oh, in this Linux box, I don't have the Docker started. So let me start it. So I just fire a command to start the Docker in order to be able to let me to run this command. Let me also enable it next time after the system reboot, the Docker will automatically start. So now, after I've done that, let me try to run this command again. Oh, okay. I shouldn't copy from the previous screen. Let me copy from the webbook again. So I just copy the command, and this time it should work. Now it's detecting the Rancher image is not there and is going to fetch from the container registry. And after a while, then it will be up and running. So it's just downloaded images. In the Linux box, it's just kickstarted. It will do some time to self-initialize itself. And after a few minutes, then it will be able to run. What we need to do is to just give it a few minutes, and then we grab the public IP of this Rancher management server. Then we can start using the user interface to help manage our uh, multi-cloud environment. Now, let's go to this public IP address. Now you can see the initial dashboard is looking for the initial password. So I just follow the instruction. I look up the container ID and check the log as is instructed to grab the initial password. Once you get it, then you can simply reset it to your own and accept the terms of use. Then you can get into the initial dashboard page where you can start managing multiple environments in here. So you can go to cluster management and get into the cloud credentials. So in the cloud credentials, you can say which cloud that you want to manage. If you want to manage AWS, for example, then you need to provide the your access and secret key that Amazon is giving you, and you point the default region that you want to manage, and then you just save it in the Ranger. Likewise, you can do the same for Azure. What you need to do is to grab the subscription ID, client ID, and secret from the Azure portal, and then you can save it here. So once you set up the cloud credentials here, what you can do next is you just go to the cluster management, and then you can start create your very first cluster from Rancher on, let's say, the Amazon EC2 instance. So what you will be doing is I'm going to set up the node template to specify where my Kubernetes cluster is going to run. In this case is in Singapore and is running on a single region. I just set up the network, and then the security group is using what Rancher is recommended. And I can specify the VM size, the instance size, how big it is. In this case, I choose a large instance to run. And then I give the right privilege, specifying the IAM instance profile. And I lastly put a name on this Rancher template. Then this is the VM template that I'm going to use to build up my Kubernetes cluster on Amazon Cloud. So I give a name of my cluster, and then this is the master node. I use this template. It should have the etcd database and the control plane. And then this is the worker node. Worker node is where your application will be running. So in this example, I just run 2 as the role for worker. There are a lot of options that you can configure, but for now, I just leave it as is. And then I just submit the create button. What Rancher will be doing is to help me to provision it, to build the cluster on Amazon. What I'm going to do now is to do the same thing on Azure. As you can see, the user experience is very similar. So the team, once they learn it, no matter where they are operating, then you are still using the same way to manage your own infrastructure. And in this case, I'm going to do it when in Sydney, and I specify the availability set that is required by Microsoft Azure, the resources group that I'm going to put in. I specify the fault domain that I'm going to do to control the resilience that I need to. Specify the network settings, and that should be it. So network security group is all good. The image, and again, it's the instance size that I need to be aware of. So as I choose any one of them that is appropriate for my workload. In this case, I just choose one of these. And then lastly, again, just give it a name. So once I finish give it a name, then I should be able to start using it. As you can see here, I just name it, and then this is my Azure cluster. Again, just one master node with database and control plane. And then you can have the worker node, and you have 2 worker node over there, and give the space to run application. And then once I save it, then it will show up again, as you can see here. So it will take a while to provision, and then after a while, maybe 10 to 15 minutes, then your cluster should be ready and you can start exploring it. As you can see here, you can see how the infrastructure is look like, how many nodes are running, how many applications are running. Everything can be seen from this simple user interface. You can see how the resources are consumed. So this is how easy it is to run the cluster management. So again, the key step, just to recap, is to capture the cloud credentials, and then you can start using it to provision it. So once the environment is ready, then let's take a look at how we can deploy the applications from there. Let me go through the live demo with my browser. So as you can see here, this is the Rancher user interface. Let me log in as an administrator. Now, this is the default homepage where you can see these are the workload that we just used. As you can see here in the cluster management, then you can see that these are the platform AWS and Azure that is available for me to deploy the applications onto it. So if I explore it, let's say on AWS, then I can see the capacity available for me to deploy my application. And likewise, I can also easily switch to check the Azure as well. So now what we can do is we go to this global apps, and then there's one option called continuous delivery. So with this continuous delivery, what we're going to do is I have this fleet examples. I have some deployment scripts to deploy applications onto one or multiple clusters. What I'm going to do is this is put it in the GitHub so that all the changes that I made will be kept track by the Git software. But then I want to make use of the continuous delivery, the fleet, to be able to help me to monitor the project that I have. Whenever there's a change, then it's a trigger to deploy the application into my target clusters. And as you can see here, this is the cluster available that I can deploy to. In this case, is the AWS and Azure cluster that we have just created. What I'm going to do is to define the target cluster group. I give them some labels to be able to deploy based on the matching label. So before that, let me check each cluster, what label do they have. Right now, they don't have much label, but what we can do is we can edit the configuration, and then we can add label here for this AWS cluster. For example, this is environment equals to dev, and I have a label for AWS, which is environment equals to dev, and likewise, I'm going to do it for Azure as well. So I just edit the configuration, add a label, environment equals to dev. So I have two clusters with the same label right now. So once I've done that, it applied, and then Azure would also have the same label key here. So now I'm going to define the cluster group that can help me to specify the application that I'm going to deploy to will be deploying to this cluster group. So for now, let me define the cluster group as cluster dev, for example, and then I add the cluster selector, which will help me to select which cluster to deploy to. So long as the selection has the matching label, then it will be included in this cluster group. So for example, I just want to include in list for the cluster that are marked as development environment, for example. Then it will tell me here two existing clusters are matching with this. Then it is the case. Then I just create, and now I have this cluster group. Then you can see that these are the target cluster that I'm going to deploy the application onto. And now what we can do is I go to the Git repo, I can create one, and I can give it whatever name. Let's say this is a simple app. What I'm going to do is to put in my Git repository here because it's public. I don't need to authenticate, but if you need to, then you can also specify the secret or the SSH secret uh, in here. So I need to check which branch it will be using. The here is the master, which is good, master here. And then I need to specify, because this has multiple things here, what I want to do is just to specify here, single cluster Helm. I want to use this as an example to deploy the application called Guestbook onto my cluster. So what I need to do is I just say single cluster Helm as the path that I am going to add to. So the path will be single cluster Helm. And then I can specify this is the target, and I want to say into the test namespace, and off we go. What it will be doing, it will just set up to keep regularly check the Git repository. And then if I look at it, then what it will be doing is to deploy the target application that I have into my cluster. In this case, is a Guestbook. So it looks like it's ready now. It happens simultaneously onto my cloud environment on AWS and on Azure. Let's take a look at this environment. Let's say the AWS one. I should have a project namespace called test. This is the case, test. And then I should have the workloads, some pods running, like the front end, the Redis here. And then lastly, I should have the service to access to it. So I can simply click on it and to access the guestbook that I have in here. Likewise, I can do the same with my Azure as well. I just check the service again to make sure it's also available to access. All right, there may be some network issue, but never mind. That is the case here. And this is how easy it is to run the GitOps here in this demo. So if you want to know more, then you can always go to this SUSE Rancher community. We have a lot of users growing every day to learn from each other how to make use of the open source technology to help them to run their application on more effectively on multiple cloud environment, and also to leverage the tools available on the open source world to help them to collaborate better, to gain better productivity. So we have a regular training, we have regular class from the experts from the development team to talk about all this approach and tools. Please feel free to join us. You just sign up from this link. And here are some further reference that you can take away if you want to understand more about what the GitOps, what the SUSE Rancher can do for you to help you to manage your whole organization infrastructure to distribute your application across multiple cloud more effectively. You can always learn from all these resources and join the community to know more about it. So with this, that's the end of my presentation today. Thank you. If you have any questions, just let me know. So otherwise, thank you.